Hello everyone, my name is Dushyant Singh Chauhan, PhD third year student, Department of Computer Science and Engineering, IIT Patna, India. I'm working under Dr. Asif Iqbal and Professor Pushpak Bhattacharya. I'm here to present my published paper, All in One, a deep attentive multitask learning framework for humor, sarcasm, offensive, motivation, and sentiment on memes. These are the outlines. The problem definition is to learn the relationships and similarities of variety of tasks such as humor, sarcasm, offensive, motivation, and sentiment analysis in a multimodal input. As we can see, humorous, motivational, offensive, and sarcastic nature of the memes are closely related. For example, in figure first B, just by seeing the text, the memes can be either sarcastic or motivational, but the image in the memes confirms that this has an overall positive sentiment, hence motivational. Similarly, in figure 1C, knowing that the meme is sarcastic has a negative sentiment makes it highly probable to being offensive. There are some challenges we face during experiments, like while certain tasks such as offensive and sarcasm complement each other, while tasks such as humor and sarcasm challenge each other. This was the main challenge we faced during experiments. And second one, non-availability of large dataset for the deep learning model. To solve all tasks together, we propose a multitask, multimodal deep learning framework to solve multitasks such as humor detection, sarcasm detection, offensive detection, motivational detection, and sentiment analysis simultaneously. For multitask, we propose two attention-like mechanisms. First, inter-task relationship module, which learns the relationship between the tasks to realize how they help each other. And second, inter-class relationship module, which learns the relationship between the different classes of tasks. Finally, the representation from both the attention are concatenated and shared across the five classes for multitasking. This is our proposed model, and there are two inputs, text and visual. For text, we use BERT, bidirectional encoder representation from transformers, and for visual, we take average pooling layer of the ImageNet pre-trained ResNet 152. Both the input vectors and TNV are concatenated and then passed through a set of 4 dense layers to obtain the vectors of equal length. These vectors are then passed through the ICRM and ITRM. The output is then concatenated and passed through another set of 4 dense layers, and a layer of softmax is applied to obtain the final output, that is humor, sarcasm, offensive, and motivation. This represents the interclass relationship module, which is used to learn the relationship between classes of all the tasks. For each task, we first group all the classes into 2 classes for the hierarchical classification of the sample. At this level, the sample is labeled with either positive or negative for all the tasks. For instance, a sample will be labeled as either sarcastic or not sarcastic for sarcasm task. Then, a loss is back propagated from using this confidence score for the corresponding task. This is done in order to control each dense layer, each dense layer, so that it aligns with the respective tasks. Meanwhile, a dot product of the software score of each task is obtained and used to form the score matrix. This score matrix will help to identify the relationship between the classes of all the tasks, and each block of this score matrix represents the 2 plus 2 matrix. Like if we have 2 tasks, humor and offensive, and for humor we have 2 classes, not humor and humor. For offensive and not offensive. After applying dot product, we will get 2 cross 2 matrix. This block represents the not humor, not offensive, and this block will represent the humor and offensive. So by using this, we can identify the relationship humor and offensive. Like humor is helping offensive or not offensive. So we can easily build the relationship that humor is helping offensive or not. Similarly for the other tasks. That this is the process of interclass relationship module. This is the ITRM module, intertask relationship module, which is used to find the relationship between the different tasks in the module. This is done by initially finding the quotient similarity between input vectors. As a result, we get the similarity matrix, which represents the how close two tasks are. To get the similarity vector corresponding to each task, we first apply pooling layer to collect information between tasks and then multiply with the cosine similarity score. This represents the similarity vector corresponding to each task. We use the dataset released in the Meme Emotion Analysis 1.0 at the rate Semivel 2020 task. This dataset consists of approximately 7,000 samples, and each sample consists of an image, corresponding text extracted from meme, and the 5 labels associated with the 5 tasks like humor, sarcasm, offensive, motivation, and sentiment. And these are the statistics of dataset. Humor, there are 4 classes: not funny, funny, very funny, hilarious. Sarcasm, not sarcastic, general, twisted meaning, very twisted. For offensive, not offensive, slight, very offensive, hit, full offensive. Amorphic motivation, not motivational, motivational. Sentiment, very negative, negative, neutral, positive, and very positive. These are the papers where the dataset is available. The project is organized into 3 sets of tasks. Task A, sentiment classification. In this task, we will classify only on sentiment. In this task, we must classify into 3 classes, which is negative and very negative belongs to -1, neutral belongs to 0, and positive and very positive belongs to +1. There are 3 classes, and these are the results, where P stands for precision, R for recall, MAF1 for macro F1, MIF1 for micro F1. Task B, binary class classification. Each task is classified into 2 classes. There are 4 tasks: 1. Humor, sarcasm, offensive, motivational. And each task is divided into 2 classes: humor, non-humor, sarcasm, non-sarcasm, offensive, non-offensive, motivational, non-motivational. And this is the result of task B. This is for STL. STL stands for single task learning, MTL for multitask learning. For STL, each task is classified separately. For MTL, all the tasks are classified together. As we can see, the dark bold color, the MTL is performing well. At the end, the task C, which is multi-class classification. In this task, the original labels are used for the tasks. These labels, for humor, there are 4 classes available: sarcasm, 4 classes available; offensive, 4 classes available; motivational, 2 classes available; and sentiment, 5 class classification. So, for task C, we take the original labels as given the dataset, and this is the results for task C. STL stands for single task learning, and MTL stands for multitask learning. This is comparative analysis of proposed approach with state-of-the-art system. Here, SE20 denotes the Semivel 2020 winner, and proposed refers to the model, which is multitask multimodal described in the paper for the respective task. This is error analysis, and we take sample attempts from the original dataset. Freshman, some seconds after the bell Mr. Bean go zoom zoom, and we show the 2 heat maps, one for ICRM, interclass relationship module, and one for ITRM, intertask relationship module. ICRM, it shows the established relationships between classes of the tasks as seen from the heat map. For predicting the above sample correctly, humor and not sarcasm, third A, and humor and not offensive, 3B, are helping each other. While ITRM, figure 4 shows the established relationship between the tasks, and we see that attention put more weight on sarcasm and offensive, while less weight on humor and sarcasm. It is clear from the definition of sarcasm that both of them have a very different meaning when used in a sentence. And we found that sarcasm and humor is not helping each other. From the heat maps of ICRM and ITRM, we can see the importance of interclass relationship module and intertask relationship module. And we can see that with the help of ICRM ITRM, we can correctly classify the sample utterance. In the conclusion, we have proposed a deep attentive multitask learning framework which helps to obtain very effective intertask and interclass relationship. To capture the interdependence, we have proposed two attention-like mechanisms: intertask relationship module (ITRM), interclass relationship module (ICRM). We have evaluated our proposed approach on recently published meme emotion dataset. Experimental results suggest the efficacy of the proposed model over the existing state-of-the-art systems. The evaluation shows that proposed multitask framework yields better performance over single-task learning. We observed the dataset used for the experiments is relatively small for training and is heavily biased. Therefore, assembling a large and more balanced dataset with quality annotations is an important job. Hence, quality implementations of the meme for effect analysis is a challenge for the future work. Thank you.